Hi, I'm Betty-Barrett. I'm the director of the Social Technical Systems program here at the University of Illinois Champaign-Urbana, and I'm going to talk a little bit about the evolution of socio-technical systems. The script for this talk and preparation for this talk was done in collaboration with Avanija Sarma. The evolution of STS is an important part of today's environment. In the 20s and the 30s, the effectiveness of scientific management began to decline as products became more complex and the industrial environment became more competitive. Frederick Taylor's time and motion studies standardized individual tasks and optimized a simple production system, but his methodology did not make the same contribution as production became more customized and tasks began to demand greater worker autonomy. Systems-based and socio-technical systems principles, such as total quality management or lean manufacturing, began to emerge. They introduced a series of work system design changes that included greater information flow, participative decision-making structures, and task rotation. All of these changes were embedded in team-based work systems. From the time that team-based systems were introduced, companies have experimented and adopted team-based systems in response to changing conditions. Japanese companies mastered team-based systems early and often provided the models that others tried to copy. In their 1995 book, Designing Team-Based Work Organizations, Moorman, Cohen, and Moorman described organizational changes required for the success of teams. So if you look at slide 1, we'll see that the first change is a change in the definition of the job. Job descriptions will vary, as will competencies and job interactions. There is increased uncertainty and ambiguity in daily tasks. The second is a change in working relationships. Workers are more interdependent with less managerial mediation of relationships, and collaborative relationships become essential. Thirdly, a change in the basic role and function of management. Authority and rank are decoupled. Leadership is assumed as the need for expertise is evidenced, and leader and follower roles shift based on the task. Fourth, a change in performance requirements. Performance measures shift from the individual to the collective, and performance requirements must also correspond across levels. There's a change in the basis for accountability, which shifts from the individual to the collective. And this makes it harder for individual contributions to be recognized. Rewards and punishments are made much more complicated in a team-based system. And finally, there's a change in the levels of commitment. Each person must work with the others to do what is necessary to achieve performance goals. Commitment to the organization and to the co-workers is the key. There is mutual responsibility. Based as they are in STS principles, these changes alter the relationships and assumptions of scientific management that shape the organizational structure and culture. In addition, these changes alter the psychological and social contracts between employer and employee. Other factors that influence the development of team-based work include forms of ownership, type of work system in place, and the balance between tangible and intangible elements. We will examine 3 types of manufacturing systems: lean, STS, and continuous, and take a close look at team structure and the tangible and intangible elements involved. The continuous production system, such as you might find it in a chemical processing line, utilizes offline teams that are not directly connected to the production process. One tangible element of this system is an ad hoc membership structure that comes into play when a problem arises and remains dormant or does normal work otherwise. In other words, these team members do not generally share a work area and come together for a specific task or decision. Quality of work-life teams are a good example of this type of team system. In lean manufacturing, the teams demand a lot of coordination due to the interdependent nature of the process. Lean production focuses on waste reduction in all aspects of the operation, so there is less buffer in the production operation within which the teams operate. Teams meet on a regular basis to coordinate activities and share information. Team leaders take on strong coordination and liaison roles, and these lean systems incorporate in-process inventory control, internal customers, and online quality control. STS teams try to optimize both the social and the technical aspects of the work. Like lean teams, they have a common work area, and strong group dynamics. These teams often have high levels of self-management, which is facilitated by their information sharing. STS teams often have great success in continuous production settings where they have a greater opportunity to interact. A final element of this discussion is a comment or two about the tangible and intangible elements of work systems. The tangible elements are often what are most evident: people, machines, and products. We are less often able to observe the intangible elements in a workplace, but they play a vital role. Intangibles are essential in systems where knowledge creation is vital to the success of the team. Intangible elements include discipline, trust, knowledge, stress, fear, and patterns of interaction. The relationship of tangible and intangible elements in a team can be illustrated as follows in slide 2. This slide illustrates a feedback process that has the more tangible elements, the workers, and in this case the suggestions. It's a suggestion program, so the workers' suggestions and cost-cutting techniques in the center, between some intangibles such as trust, learning, knowledge creation, and knowledge sharing. These intangibles are essential support factors for the more tangible process that can be actually observed. So if you will notice in the chart, there's a feedback loop created as people make suggestions based on things that they've learned. This is fed back and the knowledge base is expanded. Therefore, the next time, people are smarter and they're able to do things much more effectively. As mentioned earlier, the processes and team structures discussed so far only form the roots of the team-based systems of today. The teams have evolved over time. However, one thing that remains the same is that every team must have a level of knowledge transfer, which often depends on the degree to which the team is interdependent. This is a key component in an STS work system and a vital ingredient in success today as globalization and competition force organizations to move faster and become leaner by building on the continued input of their employees.